Bismillahirrahmanirrahim. My name is Dr. Mustafa Ali Abuzaraida. Today, inshallah, I will present this talk about learning from imbalanced data. First, let's introduce myself, Dr. Mustafa Ali Abuzaraida, Associate Professor uh, at Computer Science Department, Faculty of Information Technology, Misurata University, Libya. So the research area, AI, machine learning, and data mining. So today I am happy to be with you. Thank you very much for giving this chance to me to present this topic. So the agenda it's about this topic, introduction and so forth. Let's talk in fast so to use the time. Okay, so we have a problem called imbalanced data or imbalanced class problem in machine learning and data mining field. So it's about having a very you know very gap between two classes or more than two classes. Okay, so for example we have a majority and minority class. Let's say we have a majority and minority class. The majority class got the most number of cases, belongs to the same or to this class, while the other class got minimum number, which is called minority class. So it's a common problem which occurred due to skewed nature of data. This problem impacts the classification process negatively in learning process. Hence, balancing the classes help to train and build the data modeling in a better way. Okay. Uh, so it can reduce the accuracy rate because of training or doing the training on the mostly on the majority class, while the minority class got uh, less training. So for example, we have this type or problem, fraudulent credit card transactions as shown in this figure or this graph. The fraudulent transaction is around 400, like this one, the orange one, while the other one got, for example, 90,000 case. So if we do the training, testing, validation process, so means that the model will be trained, we will focusing our training on this class, the majority class, while the other class got less cases to do the training. Means that the model will know much about this class. So most machine learning algorithms work better when the number of samples in each class is about equal. Okay, so this is nature, of course. So all the situation will be considered and so forth. This is because most algorithms are designed to minimize the accuracy or maximize, sorry, the accuracy and reduce minimizing the errors. However, if the data frames has imbalanced classes, then in such cases, you get a better high accuracy just by predicting the majority class. In the other hand, we got less, less class, okay? Less accuracy. So how we solve this problem or how to minimize this problem? Actually, we have several techniques that we use to minimize or reduce this problem. The very famous one, we call it oversampling or undersampling. As this already be mentioned before, the accuracy score can be misleading. Why? Because the data or the model has been trained in one class. Somehow like we have a one class, okay? So comparing to the minority class, for example, like this example means that the very few number of cases means that the model will be trained just one only just one class type, okay? So for the of course the when we test this model using the majority class cases, so it's easy to get the 100% of the accuracy. But when we get another case belonging to the another class, the minority class, so the model will you know misclassify this case. Okay. So as I mentioned, okay, so resampling technique can to solve class imbalance. One of the widely adopted class imbalance techniques for dealing with highly unbalanced dataset is called oversampling or sampling, sorry, sampling. Let's say both are sampling or resampling. Means that we change the data, we remove or we add. So it consists of removing samples from the majority class. So we call it undersampling. Okay. The other type we call it oversampling, which is adding more examples to the minority class to increase the cases. Okay, to increase the cases. So the first type under sampling and the other one oversampling. Let's talk about these two main methods. Okay, so random undersampling. So undersampling can be defined as removing some over observations or cases of the majority class. Means that the data will be reduced, the data will be shrink. Okay, we cut from the cases. From where? From the majority class. How? Just randomly randomly cut some or remove some cases. This done until the majority and minority class will be equal. Okay, undersampling can be good choice when you have a ton of data. Means that you have a big data. No matter you if you remove some remove some cases, but the drawback is that undersampling is that we are removing information which is very sometimes it's very valuable to teach or to train the model. Okay. The other type, adding, or let's say adding some cases to minority class, which call it oversampling. So the oversampling can be defined as adding more copies of the minority class. So oversampling can be a good choice if we have a small data set. Okay, if we have small data set, we feed or we add more cases to make our data bigger. Okay, the problem is consider when undersampling is that it can cause overfitting and poor generalization to your test set. It's still not accurate. Okay, so we generate, sometimes we have overfitting, we duplicate some cases, so it's still not 100% solution for this problem. Okay. Now let's move to the secondary part or secondary methods. So undersampling or atomic links. It's somehow like uh, undersampling technique, but using not randomly. I mean that the data will not be removed randomly. No, it will be removed by a strategy. So it's or pairs of very close instances, but of opposite classes. Here, let's explain. So here, for example, we have this situation. We have a green, sorry, we have a blue and orange uh, squares, a cycle and square. So the majority is the blue, while the minority are which one, the orange. Okay. So how we remove the majority cases. So we will compare, or let's say neighbors of the classes. Means that we will try to find every two close cases from different class. Means that uh, for example, we have a case A and case B, which are belongs to the different classes. Okay, so we will find these the close cases, okay, they are similar, and then we remove this one, the majority case, and leave the minority one. So doing this means that we will first we will shrink the data, minimize the data for the majority class, and let's say we help the model to differentiate between the uh, you know make the gap between the classes very wide. So it's become very easy to the class or to the model to distinguish and classify correctly for every case. Okay, this is the we call it atomic links. Okay, this is another strategy. This is another strategy. Okay, the other one, the fourth one, we call it smooth. It's a synthetic minority oversampling techniques. So this technique works by randomly picking a point from the minority class and computing the k-nearest neighbors for these points. Means that now we, for example, we have this scenario, okay? The minority class is the orange class, right? So we generate, somehow we generate a new case, okay, belonging to this minority class. Means that we add more cases based on the similarity of the cases that close to each other from the same class, okay, so it's somehow different from the previous one. So means that we enlarge, or we add more cases for the minority class until we get this equal number of classes from the blue and the orange one. This is the basic steps. Okay, this is the basic steps of SMOTI algorithm. Okay, the other way, the other way we change the strategy of calculating the performance of the what they call it, the model, the performance of the model. We use other techniques. So the accuracy, not is not just the when not the only way to compute the performance of the models. So we have different strategies. So accuracy is not the best metric to use when evaluating imbalanced datasets, as it can be misleading. Okay, so we have different ways. So first, we will use confusion matrix. So it's the table showing correct predictions and type of incorrect predictions. So it's a summary. Somehow it's a summary what happened during the test, phase. So from this matrix, we can calculate the precision, recall, what methods, okay, or let's say the performance of the model. So the precision, so the first one, the number of true positives divided by all positive predictions, we call it precision. So it's also called positive predictive value. So it's a measure of the classifier's exactness. Why the recall, it's a number, the number of true positives, fraction between true positive and the number of positive values in the test data. So the recall is also called sensitivity, or the true positive rate. So we use these two, performance measurements, and also we have F1 score. It's a weight between the average between precision and recall. Also, we have area under a curve, which is representing the likelihood of your model distinguishing observations from two classes. In other words, if you randomly select one observation from each class, what's the probability that your model will be able to rank them correctly? Okay, let's stop here. So instead of using just the accuracy, okay, so we can calculate the recall, precision, F1 score, um, ROP or area under curve. So to measure the performance of the model, okay? Not just like calculating the accuracy, that's all. So anyway, uh, in this until this point, we can say that we still need other techniques to handle, to minimize this problem. To summarize, in this presentation, we have seen various techniques to handle the class imbalance in dataset. There are actually many methods to try when dealing with imbalanced data, but each technique has its drawbacks, disadvantages. However, it's recommended to continue performing research to find new techniques to minimize this problem. Maybe some of your students will choose this topic to start doing research. Maybe we use different techniques to handle and to compute the performance models, how to train the model using imbalanced data without affecting the data. So this is the most important point. I can summarize this presentation, I mean, okay? So I hope I add some new knowledge to you by doing or by presenting this topic, okay? And I am very glad to be with you and try. So I record this video, inshallah. Instead, maybe we have some connection problem, mm, any maybe during the workshop. So hopefully I add some good point of research to you. So please contact me using this email if you have any questions, if you have any recommendations, if you have any notes, if you are willing to do collaboration research in or teaching or any collaboration. I will be glad to do so, inshallah. Thank you very much, and assalamu alaikum wa rahmatullahi wa barakatuh. Have a nice day.